in the electrical current flows or magnetic fields, depending on what's requested of us. So the first couple, we're following the current from the power source. We're reaching in behind the core, wrapping it around down in the foreground. And then if you wrap your hands around this, then that means that the current's going to come down in the foreground, then the north is going to be on the right-hand side. This guy here, current goes up in the foreground. So I wrap around so that my current is going up in the foreground. Polarity is north on the left-hand side, okay? Of course, if these guys are sitting next to each other, what are they going to do? Yeah, they'd repel each other. Just remember that the notation here is long line positive, short line negative. You got to add those guys in and then start your tracing process. But these guys here, I had one person say, well, wait a minute, they're both north on the top. How is that? Because look at these guys. Look at the power source. See, the power source is flipped relative to one another? But be careful when you trace this out. Like, you actually have to trace it out. I often have students that say, oh, well, the north is always in the same direction that the positive terminal on the battery is pointing, or something like that. No, you actually have to trace it out. Because if you look at these guys carefully, notice that the windings on one and the windings on the other are in opposite directions. That's a hard thing to understand if you're not a very three-dimensional thinker. But trace it out with your hand. Check to see. This one here winds in the background first at the top. This one winds in the foreground first at the top. There's a different winding orientation. And if you play around, like if you're somebody who has a hard time like really believing in this opposite windings thing, take like a piece of string or take something like this bungee cord and wrap it around a Sharpie or a highlighter or something and check to see that you really do wind it around one way and then wind it around the other way. There's like a clockwise winding and a counterclockwise winding, if you like. Okay. Looking down the page, we got to check to see if these guys were going to attract or repel. Now, again, with these ones, we're mapping out the polarity of these, and of course, they're going to attract each other. For the last few, what direction is the current flowing? The current's flowing up in the foreground here if this is the north, because if I know the polarity of the solenoid already, then the polarity of the solenoid is going to tell me what direction my current has to flow in. And so it would have to be flowing up in the foreground and down in the background. Likewise, we could do the same thing for this one. This one's going to be down in the foreground and up in the background. And I've kind of added in a couple of different ways of communicating here. For the one on the right, I've added in just a positive and a negative terminal because the current's going to flow from positive to negative. Remember, all right-hand rules are based on conventional current flow. Somebody already asked me, should we sometimes think about electron flow as opposed to conventional current flow? No, we're only going to talk about conventional current flows when it comes to right-hand rules. And so that's what I'm illustrating here is that the current's flowing out of the positive terminal. We all know as physics folk that the electrons are flowing out of the negative terminal, but these right-hand rules were developed for conventional current flow. Okay, and so we're going to kind of just roll with that. There's going to be some purists out there that say, well, why don't we just use left-hand rules? If you're committed, you want to be committed to the cause, let's check to see if that actually works. If I use my left hand instead of my right hand, and I say, hey, if I use my left hand, then the pattern would be that the electrons flow down in the foreground for this picture. Okay, down in the foreground. That makes my thumb point to the left for my left hand. Is that going to make the polarity make sense? Yeah, of course it will. If you want to switch over to 100% left-hand rules and do electron flows, that's great, but you will be in the tremendous minority because everybody else is using conventional current and right-hand rules. I'm not against it. It's not a moral issue. It's just I like to kind of be able to talk the same language as everyone else. That's all it is, okay? All right. So a little bit of notation on this one. Could you guys add this information into your take-up? Electron flow and conventional current flow have the same magnitude, but opposite direction. Conventional current flows from positive to negative. Of course, we know it's a false idea. Hey, but all the textbooks are written already. Actually, electrons flow from the negative to the positive. And we just have to be okay with that disagreement as physics folk. And really it has to do a little bit with the history of electrons being discovered in and around the same time that people were learning to do wiring. A little historical quirk. We can say that they guessed wrong about what direction current was flowing in. And it really just has to do with what's the mobile charge. The positive charge is not the mobile charge. But conventional current flow kind of treats it that way. Thankfully, protons and electrons have the same charge, though.